Hello, welcome back to SoftwareDude. In system design, choosing the right communication strategy between components is crucial for efficiency, scalability, and overall performance. Right? Two common strategies in communication between components are polling and webhooks. Right? Each has its own strengths and weaknesses, and the choice between them depends on the specific use case requirements and the constraints of the system. Right? One of the stories that I can tell about polling versus webhook, it's a very famous real world story about Shopify. Shopify is a massive e-commerce platform, right? And its transition from polling to webhooks for event notifications, basically to merchants and third-party applications, was very famous, right? Shopify basically supports millions of stores. They needed a way to notify merchants and partner applications about any kind of changes, edits, new orders, inventory updates, shipping status, right? So one of the modifications and optimization they did, initially they used to do polling, but for the event-driven architecture, but they moved to webhooks. That really solved that. So really, how event-based applications, how distributed applications and multiple components can operate between two communication strategies, polling versus webhooks. That is what we are going to see in this video. So let's start with polling, right? Polling, basically this method involves a client periodically sending requests to the server, right, to check for any new data or any updates, right? It's very similar to asking like, is there anything new, right, at regular intervals. If the client is asking the server, is there anything new at regular intervals, right? So if you look at this image, it's basically shows that, right, the client is basically polling from the server, is there a new data? Server is responding no. Is there a new data? No. So that is how polling works. One of the ways to reduce, like, stay with polling but not obviously bombarding the backend or the server with multiple requests is called long polling, right? Long polling, basically in this situation, the server keeps the connection open until the new data is available, right? So that basically reduces the number of polls that the client has to make to the server, right? So what are the use cases in which polling is used? One is periodic health checks. Obviously, anything that has to be done in at a regular interval, right? Like periodic health checks, frequent synchronization tasks, right? Or say notifications, status updates, like anything of those cases. Polling is a good option to check for data from the backend at a regular interval. Next is webhooks. In webhooks, it's a server-side push mechanism, right? Where the server sends a post request to a specified URL, right? That URL is basically the client's endpoint, right? When any data or any event is available, right? In this situation, it's like the server is saying, here is the new data, take it. Here is the new data, take it. As soon as there is a new data that is available, right? So if you see here, the client basically provides an endpoint, a URL to the server, and whenever there is a new data that is available, that endpoint is always open, right? And whenever there is new data that is available, the server basically sends that new data through that channel to the client, right? One of the cases in webhooks is obviously the length of the connection. That's a caveat in which how long do you keep the connection open. At times there are different kinds of webhooks that are available in the market. Webhook solutions, and the default client timeout can also, like the connection timeout can also be one of the factors, in which case the client can basically, whenever, say the connection timeout is 5 minutes, right? So the client can re-establish the connection so that the perceived connection is never dropped, right? So where is webhooks used? Webhooks is used in any real-time messaging application, right? Any real-time messaging application, whenever you type a message, that message has to be sent to the client, and there are multiple clients that can be registered, right? I mean, it need not be a user might be having multiple devices. They can be checking through their mobile device, their laptop device, their other devices, their notification systems in their smartwatch, right? So how whenever the server has the data, it basically pushes that data through the webhook connection to the client, and that client can be, there can be multiple clients of the same user, right? So any kind of real-time messaging application, payment processing notifications, event-driven architecture in any case also sometimes use polling, but in this case it's like a it's kind of a push mechanism, it's not exactly a pull mechanism, right? So that's webhooks. Now, what are the trade-offs between polling and webhooks? First, let's look at latency, right? In polling, the latency depends on the polling interval, right? Depends on if you are polling every minute or every hour, right? The frequent polling can reduce the latency, right? But it increases the number of requests naturally. So you have to pace it out. How often do you want to poll the data, right? If it is kind of a job, or if it is kind of warm data, which is like write once, read many kind of data, like low frequency change data, at that point of time polling can occur even an hour, or maybe once in 6 hours. Long jobs can be polled at smaller intervals, but at that case your latency might be more because you are waiting for 6 hours, so the data size will be quite large, right? But if you are in polling at a much frequent interval, then in that case obviously there will be a lot of requests, but the data between two polling intervals will obviously be less, right? So that is one optimization in latency. Now, webhooks, the data is delivered immediately, right? Upon occurrence of an event, like whenever the data is available, server is going to basically send the data out to the client, right? So latency is obviously almost near real time. Next is resource usage. Uh, Polling can be resource intensive because obviously of the repeated requests, like we talked about. It can there can be, depends on the server's load, it can also throttle the server. It can also cause skewed metrics on your backend, right? Because if you are getting multiple pull requests from the client, you might not really know whether that is coming from the client as to check for data availability, or if the endpoint is shared with, say, a user request, then in that case whether it is really a user making that call, right? So there can be problems in that case. Like, it is very resource intensive because of the number of requests that have to be made from the client to the server. But in webhooks it is obviously much more efficient because data is pushed only when it is available, right? So it's not like a periodic or like a continuous repeated request that comes. It's only on demand, so to speak. Third is scalability. Uh, Polling, obviously, because of the number of requests and depending on number of clients that there are, which are polling from the server, it may not scale well, right? And when in today's application, like I talked about, like if yours is a multi-tenant application where each tenant can have multiple users and then each user can have multiple devices, right? So in that kind of a situation, a single data will also be pushed on the users smartwatch, mobile, laptop, or web browser. Like, so there are multiple places where the data, so the permutation and combination of the number of clients that are making the call at multiple periods, right? So it's a n is to n kind of a problem, which becomes scaling a challenge, which makes scaling a challenge for pooling. But for webhooks, obviously it scales better because it can reduce the redundant communications, right? I mean, so naturally it scales much better. Fourth is reliability. Polling is typically reliable because the client initiates the request, right? So you are not dependent on the server to push the data. So that is where it can be useful. So if a client misses, so one poll because of some issue, it can again retry, right? So it will do that continuously over a period of time at regular intervals. So there is some dependability, you can be reliable, right, in that sense for polling. But in webhooks it depends on the server's ability to deliver, right? And that is where, if there is a failure in the delivery, or if there is a failure in the event notification for the server to send it to the client, right, in that kind of cases, the backend or the server really have to handle retries. It should be able to capture, it should be able to queue requests so that that event is not lost, right? Because there is no one asking for that data, right? So it is completely on the server's responsibility to send it out. So which is where it can if you are obviously implementing it with multiple retries and with jitters and back off and everything, and you are stable in the server, then webhooks is also reliable. Complexity, because obviously implementation wise, polling is much simpler. It's much simpler to implement from the client side. You basically provide an endpoint which the client will periodically call over a period of time, right? So that becomes much simpler. But webhooks, because of multiple things that we discussed here in terms of maintaining the connection, maintaining that the connection is alive, managing failure scenarios, managing throttle scenarios, managing whether your data is retried, idempotency, right, immutability in terms of if you are sending, say if you are one of your requests is failed and you are retrying and that request is not sent twice, so how will that be handled, right? You can't let the client handle duplicacy, you can't let the client handle um, delivery guarantees, right? So it's all dependent on the server. So implementing that can be complex, but obviously when you are working on a large scale distributed application, it is anyways not a simple application, right? So in that case, when depending on the scale, so webhooks can be a better decision to take, even if it is much more complex. But having said that, in some cases I've also seen that a hybrid all approach also works, right? I mean, it depends on your use case. Like for example, you can use webhooks whenever you need immediate updates, like almost near real-time updates, right? But you can use polling as a fallback mechanism to basically ensure that like data consistency, or maybe handle missed webhook deliveries, right? So then in that case, you can have polling as a failover or as a fallback mechanism, right? So choosing between polling and webhooks involves evaluating the specific requirements of your application, like by carefully considering like at least these five main scenarios or factors in terms of latency, resource usage, scalability, reliability, complexity. You can select the most appropriate communication strategy for your system. I mean, in today's world, you can realize while there are notifications and where there are data passing almost happening between components at every point of time between the client and the server, implementing a robust communication strategy is very key. So depending on your use case, you can use polling, you can use webhooks, or you can also use a combination of both the approaches to leverage basically their respective strengths, right? So that was the system design trade-off between polling and webhooks. Hopefully this was useful. Thanks for watching.